everyone. Welcome to our word games session. We have a lot to get through today with our client and creating our very first, and testing, I should say, our very first prototype of this game. So in order to get started, I will of course share my screen. So behind me you should see my screen, and I'll hide in the corner here. Let's go ahead and take a look. Now, we have some fairly loose requirements from our client. The only core stipulation is that we need to simulate at least a single turn of the game of Scrabble. There is also one core piece of information here that we will not be considering blank tiles in this version of the game, but we can think, well, maybe in the future we'll need blank tiles, so I wouldn't rule that out. That's why I said it's a soft requirement there. The very first thing that we want to do when tackling a problem like this is, of course, well, make sure that we understand the rules in the game of Scrabble, but very importantly, use that knowledge to then break down our problems into smaller pieces or smaller chunks. I often refer to these as our derived requirements. And so these are going to be self-created, of course, all being derived from our core requirements here outlined by our client. Well, if I need to simulate a single turn of the game of Scrabble, I'm probably also interested in drawing n tiles from a population of tiles. And once we have, the tiles in our hand, we need to figure out what words can we make. So using the above n tiles, we need to figure out what words we can make. Then, from that list of candidate words, we'll need to wrap up by figuring out what is the best word we could play, and we'll need another piece of external information here. That will be some associative or associated points for each tile or for each letter in this case. And so we would probably say using some associated point values for each letter, determine the highest scoring word we can make. Now this breaks down my problem into something that's a little bit more easy to program against, and this is probably going to be my very first starting point. Based on the way that I've broken this down, I'm not going to necessarily step through first and then second and then third. What I like doing is figuring out what the smallest problem here. And I think each of these pieces can actually be developed in parallel. Now, of course, since I'm working by myself, I won't be able to develop them in parallel, but I should make sure that I can work on each of these pieces completely separate from each other. That's going to help me out later writing tests, and if I ever have to come back and refactor or revamp a portion of this code, if I've created myself just a hierarchy of code, well, if I need to change this middle bit, we're probably going to need to change the pieces that come after it. But if I develop them all independent from one another such that they interact with each other, but they do not necessarily rely on each other, then I can swap out any of these given steps as I please, which will really make my life a lot easier because I know that the requirements of today are not going to be the requirements of tomorrow. So let's start out here and just create a very basic implementation. And I'll start with probably figuring out what words we can make using some predetermined tiles. That sounds like a very straightforward requirement or straightforward piece that I can tackle here with some code. So what I'm saying is if I have some words, right, and we'll say that my list of possible words, classic hello worlds, and maybe we'll have a third word, test or tiles, and then, well, this is Python, of course, so we'll use Python as our final word. Now, I have some words, and I also have some tiles. And how I represent these tiles may not be important to me just yet. What I would like to do before I really harp on what data structure do I use to represent each tile, do I create a custom data class, do I use a named tuple? Well, I just start with the simplest and the most obvious thing, and as I'm prototyping, if I need more complexity, I can always reach for that more complex object. But for now, I'll just use a list of strings where each string is a single letter. And so One thing that I'll do is I'll probably start by using all of the same letters as exists in one of my words here, because this will give me kind of a known input and known output to just prototype against. So we get into the kind of tricky portion here of, well, how do I test if I can use the tiles in my tiles variable to compose any of these words? Well, one thing that I might do is I might just naively go through each word, and I might say if the word is equal to the string version or the joined version, right, of my tiles here. Then we can say that this is our valid word. And this works out quite well for us. It does pick up the matching word. But if you ever play the game of Scrabble, you don't sit there and have nicely and beautifully sorted tiles in your hand that you can always make a word with. Sometimes they're going to be a little out of order. And that ordering should not be dependent or should not dictate what words I can and cannot make. And so you'll see if I run this code after switching the O and the N, all of a sudden it doesn't work. I don't pick up that Python that I was expecting. So maybe, well, I need to sort these words first, or sort these, I should say, tiles first, and maybe I could sort the tiles and write the word itself, and then I wouldn't need this dot join here. Here we get Python, but what I'm also missing is what if I have another word that exists, or another word that works here? What if, for example, in addition to Python, I have the letters to spell think? And here you can see I have a TH embedded here. I have an I just at the end, and then I have an N, and I'll need to add a K, and I actually don't need that second T. So now I have the letters for the word think and the letters for the word Python. So I should be able to pick up both of these if my implementation here is correct. You can see now that I've added extra letters to my tiles, I'm actually not picking up anything. And I can even show this to you, right, with a quick print here. So you might be thinking, well, how do you get this to work then? How do you get this approach or this algorithm to work? Well, one thing that we might consider is instead of working on some sorted version of tiles, I might actually start counting each of these tiles. And by counting each of these tiles, I'm strictly referring to the idea that if I have some letters in my hand, and I have an enumeration of all the words I could make, well, the words I could make should all have some count, right? Some quantitative value of all the letters that are composed in them. Additionally, I can check my tiles for the same thing. So what if I swap out my simple, naive kind of sorted approach here for something a little bit more intelligent? What if, instead of working with just very simple tiles, I create some counts of tiles? And so I could say my tile counts here is an empty dictionary, and then I could iterate for each letter in tiles. Just print out each letter, make sure we're at a working state in our program. Excellent. And here, I could do something like this. I could say tile counts is equal to the current tile counts.gets, and we'll grab each letter, and then we'll just say +1. Just like this, and that looks good. Tile counts.get, perfect. And tile counts, of course, should be using this square bracket notation. And here we go, we have a count of all of our letters. Just very quickly, I do want to also figure out, make sure this is working well. So if I have the word hello in my tiles, I should have 2 L's, 1 O, 1 E, and 1 H. And you can see we do capture that. We have 1 H, 1 E, 2 L's, and 1 O. And now I could take this count of my letters and do the same exact operation for the counts of the letters in each of my words. So I would likely do something like this for W in words. And then I would say probably the word count word counts here, just like that, and then I can grab my own code, recycle a little bit of this logic. Iterate through each letter in each word, and then grab each letter. Now let's take a look at this. Here we have the representation of both of these parts. So I have my word hello, and then I have a single H, a single E, two L's, and then one O. Now, naively, I could just say, right, if tile counts is equal to word counts, we'll print out that word, and I get the word hello back, but we'll run into that same problem where what if I have extra letters here, then all of a sudden this matchup doesn't work. Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.